Hello and welcome to the Graphing Trig Day 3 video. In this video, we're going to continue what we've been learning in our first two videos. We were looking at graphs and equations, finding all of our features and writing the equations. And now we are given our equations, we have to find all of our features and draw the graphs. So it's really just working on the visual representation on these features we've been finding. So before we get into all the special kinds of features, what they may look like, let's just look at the parent functions of sine and cosine. So first we're going to start with y is equal to cosine of x. Now if we're going to use all of our different colors and vocabulary, we would say this is 1 cosine times 1 of x minus 0 plus 0. So this is where our amplitude is 1, our frequency is 1, our period, we'll get to that in just a moment, our phase shift is 0, and our midline is 0. So this is the most basic kind of function. There's no features, it's not being stretched or shifted at all. It's really just, here's what we have. So when we scale our graph, we want to make sure that we see either from negative 2 pi to 2 pi or from negative 360 to 360. I'm going to zoom in before I start making my scale just so it's a little easier to read. I don't know exactly how to lock this in place. So our y values are going to be whole numbers, but our x-axis is either going to be in radians or degrees. So I'm going to do radians, the stuff with pi. I'm going to have every kind of block be pi over 4. So if that's pi over 4, this is pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So you can scale this however you want. I'm just kind of doing it so if you look at the unit circle, it's like I'm hitting each of the quadrants, and that makes it a little bit easier for me. We'll also make sure to do this same thing going in the negative direction. Feel free to pause at any point so you can graph this on your own. But this is just in the blank notes that you can see. So let's see, this will be 1 and negative 1. That's all we're going to need there. So when I take a look at this, this is everything that we have for cosine. Now for our period, we haven't really talked about our period yet. For our period, there we go, we're always going to do 2 pi divided by the frequency. So in this case, since the frequency is 1, we're going to do 2 pi divided by 1, or 2 pi. So this tells us we're going to complete one full cycle in an interval of 2 pi. And the best thing about this, before I start actually graphing cosine, is that all of this information is actually going to be the same for sine. So I'm going to pause the video for a moment, try to figure out how to copy and paste. I'll put that below and we'll deal with that in just a moment. All right, I am back. I figured out how to copy and paste. I'm very excited with myself. So feel free to take a moment, pause, do what you need to do. The only difference between the parent graph of cosine and the parent graph of sine, oops, that's eraser is not doing what I want it to. Oh, I guess we cannot erase there. Interesting, good to know. Can I erase up here? I can erase up here. So we're just going to change this top one to the parent graph of sine. And we'll have the bottom one be cosine. There we go. So we'll actually work with sine first, I guess. So in this case, the only difference between the two is where they're starting. So we have to think about our unit circle. Now again, I'm going to start with sine now at the very top, then we'll get to cosine at the bottom. So when we're starting with sine, I have to think, okay, well sine is my y value of the unit circle. So I think, okay, when I have 0 radians or 0 degrees, what's my y value of my unit circle? Well, that's just 0. So I can start at 0. Now let's move to our next part over here at pi over 2. So for pi over 2, that's the same as 90 degrees. So what's the y value coordinate at pi over 2 or 90 degrees? The answer is 1. So we're going to keep going around in that manner. So at pi, or 180 degrees, what's the y value? 0. At 3 pi over 2, or 270 degrees, what's the y value? -1. That's going to kind of get mixed up in there. And then at 2 pi, what is the y value? Well, 2 pi is going to be the same as 0, so that's going to be 0. So when I graph this, it looks something like this, where I can see that my midline is on the y-axis, my amplitude, or the distance from the midline up to the midline down, is 1. My period, it takes 2 pi to repeat itself. And then the frequency, it tells us that, hey, we have 1 full cycle in an interval of 2 pi. So we want to make sure that we can go through and graph from -2 pi to 2 pi. Now, I was kind of counting specifically from the unit circle, but you can also use a graphing interval. So a graphing interval, oops, this is still the highlighter. We want the pen. There we go. A graphing interval is when you take the period and divide it by 4. It just says how far apart should our points be. So in our case, since our period is 2 pi, if we take that and we divide that by 4, we end up with pi over 2. So we can see that each of our points that we graphed is just pi over 2 distance, or in our case, 2 squares. So now that we've graphed from 0 to 2 pi, I want to continue this pattern backwards. So since we started with going up, now we're going to start with going down backwards. So at -2 pi, the y value is -1. At negative pi, the y value is 0. -3 pi over 2, the y value is 1. And at -2 pi, the y value is 0. So we're kind of continuing the curve in the other direction. So this is the parent graph of sine with all of the information that we need. So like I said, the only difference between sine and cosine is its starting point. I'm also going to do something that we're going to do in later on problems. It's going to help us out a little bit. So I'm going to move this down just slightly. There we go. So first thing I see is our midline's at 0, so I'm actually going to mark in my midline, just like this. And I also see my amplitude is 1, so I'm going to count up 1 from the midline and dash that in, and count down 1 from the midline and dash that in. So all of my points should be somewhere on these dashed lines. It's either going to be at the very top, in the middle, or the very bottom. So this kind of tells me where I should be graphing. Now, as far as our starting point for cosine, I ask, hey, at 0 degrees or 0 radians, what's the x value of the coordinate? Well, the x value is going to be 1. So we're actually starting at the very top now instead of in the middle. So when we use, let's say, our graphing interval, if we wanted to find that, we're going to do our period divided by 4. And since all the information is the same as our parent graph for sine, our graphing interval is going to be the same. So it'll be 2 pi divided by 4, or pi over 2. So we're going to mark up every pi over 2. So what is the x value at pi over 2? What's the x value of that coordinate? Well, that's going to be 0. How about pi? What's the x value coordinate at pi? Well, that's going to be -1. At 3 pi over 2, our x coordinate is 0. And then at 2 pi, our x coordinate is 1. So we can see we have this curve here, or a frequency of 1, because we were able to complete 1 full cycle in an interval of 2 period. In an interval of 2 pi, excuse me. So now it's up to us to graph the other direction, and we're just going to continue downward and back up. So we're just continuing that curve. Please make sure to stick arrows at the end of your graph to show that this is going on and on forever. So these are our parent functions for both sine and cosine. Now it's going to be up to us to go through and apply all of our transformations. So I'm going to spend some time doing two different problems with you, and I think I'm going to do it in a separate video. So this is the parent graphs. The next one will be for the transformed graphs.